The flow of energy between Earth and space sets the stage for climate variability, and climate change. The AMS conceptual energy model illustrates some fundamental aspects of this flow. Units of energy are tracked on a game board according to simple rules applied to different scenarios. The game board has circles at the bottom to position units of energy at Earth's surface. Scenario A investigates the flow of energy in a climate system composed of a solid Earth surface but with no atmosphere. We begin with 1 unit of energy at Earth's surface. This energy originates from the sun. The moves in each play are displayed in 2 steps. First, arrows appear on the existing energy units on the board in sequence. This shows the direction of motion. A set of random numbers was used to determine whether that motion is up or down. Consequently, each direction has an equal chance of being selected. Next, the energy units are moved simultaneously according to the depicted arrow directions. Energy units move up or remain at Earth's surface when the direction is down. Upward moving energy units that enter space will be depicted by dashed open circles. After the moves are played, an additional unit of solar energy arrives at Earth's surface to end that cycle of play. Then the energy units in the different parts of the board are summed and displayed in the upper center portion of the activity board. The activity then moves on to the next cycle until all cycles are played. Scenario B investigates the flow of energy in an imaginary climate system composed of a solid Earth surface and an atmosphere whose upper boundary is shown by the horizontal blue line across the board. The play of Scenario B is started with the same initial conditions as in Scenario A, with 1 unit of energy positioned at Earth's surface in the circle farthest to the left. Scenario B assumes that any energy unit moving upward from the surface would be absorbed into the atmosphere and remain there until the next cycle of play. Once in the atmosphere, the energy unit has an equal chance of going up or going down in its next move. This represents what would happen in a real atmosphere, since real molecules radiate energy in all directions. Half will radiate downward and half will radiate upward. Any energy unit moving upward from the atmosphere would be lost to space. Any energy unit moving downward in the atmosphere returns to the surface. In Scenario C, a double-layer atmosphere is demonstrated. This is comparable to doubling the amount of carbon dioxide in the atmosphere. Different scenarios are played out to model real-life situations in which certain variables change. Play through each scenario and compare the results. Compare, for example, the amounts of energy that are lost to space at the end of the 10 cycles and the amount that remain in Earth's system. This has been a presentation of the American Meteorological Society.